Hi students, we're going to be looking at graphing tangent and cotangent today. There are a couple of big differences that we have to be concerned with tangent and cotangent compared to sine and cosine. The first is that our period is pi instead of 2 pi, so these are going to repeat themselves every time that we go pi units. Another way to think about that is unlike sine and cosine, where we have this nice uniform single wave, we could think about tangent instead, and this is a little bit mathematically questionable, but it's okay in terms of understanding the graph shape, as repeating this image twice over the course of pi instead of 2 pi. We're also going to make use of understanding a little bit about the unit circle. We know that tangent is going to be y over x. So anytime that we have an x value of 0, and by the way, that was not meant to be a y-axis, they're just to kind of mess with us even further. So anytime that our x value would be 0, tangent of these values is undefined. So if we're thinking about the way that our graph is going to look, it'd be nice if I could spell, we're going to have some asymptotes going on every time tangent is undefined, every time cotangent is undefined. The graph shapes for tangent and cotangent are going to be remarkably similar. They're going to be shifted and flipped a little bit to make some sense of that. We'll talk a little bit about that when we deal with graphing these things. All right, so for my first thing, we were looking at graphing tangent. And just to remind us, the tangent graph shape looks like this. Initially, we'd have a inflection point at 0, 0, and that's going to be one of the key points that we use for this. The other points that I really care about are the asymptotes, where the asymptotes themselves are going to occur whenever we would be inputting either pi over 2 or 3 pi over 2 into our graph. Another way to think about this would be to set up some beginning and end points for our cycle, because you may have noticed that I had 0 in between pi over 2 and 3 pi over 2. In my verbal explanation, that doesn't make a heck of a lot of sense. So let's tackle this a little bit. So we're going to look for some asymptotes. And those are going to be when the inside is at pi over 2. So I'm going to set this up as pi over 2 equals 2 theta plus 5 pi over 6. Getting 2 theta by itself, I need to make sure I move some stuff to the other side. So I'm going to minus 5 pi over 6 to both sides. And I know that a half is really 3 pi over 6. So that's going to be negative 2 pi over 6. And if that's equal to 2 theta, we'd end up with 1 pi over 6 is going to be 1 theta. So let's just kind of set this up. So we've got negative 1 pi over 6. And that's going to be our first asymptote. Okay. The next asymptote, instead of being at pi over 2, would happen at 3 pi over 2. And I'm going to set that equal to the same equation, 2 theta plus 5 pi over 6. That's going to give me 4 pi over 6 divided by 2 is 2 pi over 6. And that's equal to theta. I minused 5 pi over 6 to both sides, then divided by 2, which is where I got that as my answer. I'm going to leave that unreduced so we can keep things in the same kind of form there. And if I keep my spacing somewhat equivalent, we end up with 2 pi over 6 as our second vertical asymptote. If you're so inclined, you could go one step further and add a third asymptote, but I'm just going to kind of leave this as is. Okay. So we have some values to think about here. I know that for my asymptotes, I chose pi over 2 and 3 pi over 2. To get a point that's going to be on the tangent equivalent of a midline, I'm going to have to choose the value that's between these two, which is going to be pi. So I'm going to set this up here for my 0. And this is going to be with pi, that's my 0, that's where it would normally be on the midline, is 2 theta plus 5 pi over 6. If I minus 5 pi over 6, I get pi over 6 divided by 2, I get pi over 12. I'd also like you to notice that if this is pi over 6, so we can keep our graph having an even scale, that even visually I can see that between 0 and pi over 6 is going to be the middle of these two asymptotes. So we have this pi over 12 piece that we have to worry about. Okay, now I'm going to worry about the rest of this stuff. So I've got minus 2 as my midline, so let's make that just kind of sit there. Y equals minus 2. And the only thing we haven't talked about is the amplitude here. From the midline, so we have tangent getting our midline point there. Halfway between, or like trying to get one point between these center points and the asymptotes, that's going to be what that amplitude is really covering here. The problem that's going to happen with this particular tangent graph is that our numbers are so gross because I chose a random problem that we're going to end up with a really kind of disgusting function here. So let's think about what that might look like. So we know the amplitude is going to give us 3 above, so that's going to be y equals 1, and 3 below, y equals negative 5. For tangent, that point is going to fall exactly between the midline at pi over 12 and the asymptote at 2 pi over 6. If I average those 2 points, that's going to give me 5 pi over 24, which again, I told you is not the most pleasant number. And looking backwards, the same thing. If we are looking exactly between pi over 12 and negative 1 pi over 6, I think that should be coming out to like negative 1 pi over 24. And let me just put that on here. So negative pi over 24. In class, I will try to avoid giving you ones that are this unpleasant, because we can't even really see where this goes off our paper, but we have a nice tangent curve kind of going through there that way. I'm going to ask for one tangent or cotangent curve, and just kind of thinking about things as they go. All right, looking at cotangent, the first thing to do is understand what cotangent looks like. So I'm going to take a moment to just think about my unit circle. Cotangent is the reciprocal of tangent, so that's going to be x over y. I'm going to have asymptotes at anywhere that y is 0. And I'm going to have zeros anytime that we have a pi over 2 or a 3 pi over 2. So in terms of this type of setup, I'm going to do my asymptotes first. And what happens sometimes is that we think about where our tangent or cotangent graph is, we have to be aware of kind of where our graph is positive and negative so we can see what that shape is. In quadrant 1, we're going to be positive. In quadrant 2, we're going to be negative. So if we think about what this means about a cotangent graph, our cotangent graph is going to have a couple of asymptotes. And if I'm looking just at one cycle from 0 to pi, we're going to start positive and we're going to go negative. So it's going to be the reciprocal of a tangent graph, which is going to cause it to move to the side because of where that midline is, and produce a graph that's also looks like a reflection of the tangent graph. Okay, I'm going to build my equation now. So we're going to start off with my first asymptote, and that's going to be at 0. So 0 is equal to 2 theta minus 11 pi over 6. If I add that to the other side, divide by 2, I get theta is equal to 11 pi over 12. That's my first asymptote. Let's do my second asymptote. I'll do this one in blue. That one's going to be based on pi. So pi is equal to 2 theta minus 11 pi over 6. If I add that to the other side, that's going to be 17 pi over 6. And then divide by 2, we get theta is going to be 17 pi over 12. That's my second asymptote. Let's get the 0 that's between those two. That's going to be at pi over 2, which is going to make this even more pleasant. So we get pi over 2 is equal to 2 theta minus 11 pi over 6. I'm going to add that to the other side. That's going to be 3 sixths plus 11 sixths is 14 sixths. When we divide that by 2, we get theta is equal to 7 pi over 6. I'm going to write that as 14 pi over 12 just to keep everything in the same units. Okay, we've got a midline of 2, and we've got an amplitude of 1/2. So when I set this up, and all of my numbers are positive here, so I don't need to be at the axis, I know that plus 2 is going to be my midline here. And if I go half above and half below, those are going to be my amplitude points. Okay, now let's set some things up. So we've got our first point at 11 pi over 12. That's going to be an asymptote. We've got our last point at 17 pi over 12. That's going to be an asymptote. If you didn't feel like doing this calculation, you could also add those up, divide by 2. 28 divided by 2 is 14. That's where we get that number in the middle. And that's going to be my midline for the cotangent graph. So this is at, we said 14 pi over 12. This is when we have to get a little bit messy in terms of numbers. So we've got to get a point between these two, between 11 and 14 is going to be 12.5. And I'm going to leave this as a lovely decimal fraction, which you know is our favorite thing. Although you could write that as 25 pi over 24, and that would be okay. And that's going to be my first point. Then between the other two, 14 and 17, is going to be 15.5 pi over 12. Again, it's exactly between those 2 points. Cotangent has a shape that goes from top to bottom. So we're going to get our points there, match those asymptotes, and give us a nice curve. Hi students, we're going to look at graphing secant and cosecant today. The method we're going to use for these is to connect these to sine and cosine. So secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. We know this because they kind of go with the wrong letter. So to graph secant of x, again, I'm going to think about the graph of 3 cosine of this same thing on the inside, and then use that to graph my secant equation. So I'm going to think about cosine, which we know looks like this. We know that we're going to have a period of 2 pi, so we're going to have a starting point at whatever makes the inside 0. So theta over 2 minus pi over 6. If I add pi over 6 to the other side and multiply by 2, I get theta equals 2 pi over 6, which would be pi over 3. I'm not going to reduce that right now because we may end up having unreducible sixths later, and I'd rather kind of have that working out for us. Second thing that we need is an end point, which is going to be 2 pi is equal to theta over 2 minus pi over 6. That's going to give us 12 pi over 6, 13 pi over 6. And then if we multiply that by 2, we end up at 26 pi over 6. Again, we may end up with some unreducible sixths, but we may not. The point exactly between those, so if I do 2 plus 26, that would be 28, not 18. If I divide that by 4, I'm going to end up, like how I said divide both by 4, I meant divide by 2. I'm all over the place today. I end up at 14 pi over 6. That's my lowest point. In fact, if I begin to sketch this graph, so we know that we're looking at y equals 2, that 5 and -1 are going to be our top and bottom for cosine. And now we have some good stuff to work with. So we've got a beginning point at 2 pi over 6. We've got an end point at 26 pi over 6. We've got the nice middle point at the bottom at 14 pi over 6. We've got 2 points left to figure out. Between 2 and 14 is going to be, adding those up, we get 16 divided by 2, 8 pi over 6. And then same thing on the other side, 14 and 26 is going to be 40. This is going to be half of that, 20 pi over 6. Okay, all of those would have reduced. We would have been fine. So here's the thing. Here's our cosine graph. To get secant, we need to think about this as the reciprocal of this. And any time that we have a 0 on the midline for cosine, dividing by 0 would cause that to be an asymptote. So I'm going to start off by putting some asymptotes in. Those are going to be at those 2 points, which I clearly drew under the right places, so that, there we go, at 8 pi over 6 and 20 pi over 6. The next thing we have to do is realize that the points that are supposed to be 1, if you divide 1 by itself, you end up at the same thing. And the last piece is that secant and cosecant look like the same thing as sine and cosine, but it's like you're taking this and you're flipping that part of the graph between the asymptotes over. So in my very, very neat drawing, we get like a series of upside down U's between these asymptotes. So my final graph would be the blue part. Basically, we graphed cosine of that function and then just turned that into cosecant by adding asymptotes and flipping those values. We're going to do the same thing. I think I said cosecant on the previous page again. I'm all over the place today. For cosecant, we're going to graph sine of this function. So theta over 2 plus pi over 2 plus 2. All right, same thing. We're going to do a starting point. We got theta over 2 plus pi over 2 is equal to 0. That's going to give us theta is negative pi. We're going to do the same thing. Theta over 2 plus pi over 2 is equal to 2 pi. When I add that to the other side, we're going to end up getting theta is equal to, that should be like 3 pi over 2 times 2, 3 pi. Okay. We know based on that what our graph should look like. I'm going to do this in blue. So we know at positive 2, we're going to have our midline. Go up 2 more and down 2 more. Those are going to be our amplitude lines. At negative pi, we're going to have our first point for sine, which we know looks like this. At 3 pi, so that would be pi, 2 pi, and 3 pi, we're going to have our second endpoint for sine, exactly in between these two. So exactly between negative pi and positive 3 pi should be 1 pi. We can tell that my graph is very, very well to scale. because those look totally even, and that's okay. We know that exactly between those two, which would happen to be at 0, we'd have a peak, and that exactly between our second two, which would be at 2 pi, we'd have our bottom for this graph. It's nice when the numbers work out really nice for us. Sine would normally be a curve that would look very much like this. For cosecant, first thing I'm going to do is take my midline points, and those are going to become asymptotes, because that would cause us to divide by 0. Second thing I'm going to do is take my max and min points, and those are going to be included on my cosecant graph. Those should be a value of 1. 1 divided by itself is going to be 1. Then I'm going to turn these into u's. What I need to see for secant and cosecant graphs, just like for tangent and cotangent graphs, is where are my asymptotes, and give me a couple points so I can see that you know where these come from. It would be very helpful to me if you graphed the sine or cosine function first so that we could see where that came from as well.